Okay, Paul. So, as we normally do, let's start this virtual planetarium looking at the solar system. And we'll begin with the planet Mercury, which is, let's face it, it's a bit rubbish at the beginning of October, but it gets better as we go through the month.
Yeah, that's right, Pete. It's really badly placed at the start of October. It's in the evening sky, but the planet virtually sets at the same time as the sun, so not terribly good. And inferior solar conjunction occurs on the 9th of October, whereby Mercury rapidly re-emerges into the morning sky and it brightens up as it does. And because Mercury moves quite quickly, it's probably you'll see it on the 18th of October, and it moves quite quickly around the sun, which means it reaches greatest western elongation a week later on the 25th of October. So not long to wait once it's passed through its conjunction with the sun.
No, it moves pretty quickly, doesn't it? Actually, on the 25th, it will have brightened to magnitude minus zero point 0.5, which is not too bad for Mercury, and it rises 2 hours before the sun, and it remains favourable, actually, right the way through to the end of the month. So towards the end of October is the best time if you want to spot Mercury in the morning sky. So you'll have to get up early to see that one. Okay, let's head out to the planet Venus. And Venus is more convenient because Venus is in the evening sky. But unlike the last evening apparition we had with Venus, it's really badly placed. So it's actually not a lot of people have seen it, have they?
No, it's been quite poor. If you want to catch it in the evening sky, it's been quite difficult. It reaches greatest eastern elongation. This is its maximum distance from the sun in the evening sky on the 29th of October. It's quite a good separation. It's 47 degrees. But because the planet's position is very poor, it's still going to be very low down. And so what a lot of dedicated Venus observers do, myself included, we tend to observe the planet during the daytime. And there's a number of benefits for that. First of all, the planet is well away from the sun. So you're not going to catch the glare of the sun. It's much higher in the sky, so not affected by seeing, which it always is when it's low down. And then finally, the brightness of the sky really reduces the glare from Venus's cloud tops. So imaging and drawing is much easier. So that's I haven't noticed the planet in the evening sky because my Venus observing is done by the time the evening twilight falls. So that's probably the best time to catch it.
Okay, well, it's also worth pointing out that, as you say, Venus reaches greatest eastern elongation on the 29th of October, and it will be separated from the Sun at that time by 47 degrees. But the angle between Venus, the Sun, and the Earth is a right angle at that time, so 90 degrees. And in theory, the phase should be 50%. But there's a thing called the phase anomaly, which means that Venus reaches its 50% phase or dichotomy a few days earlier than it should in the evening sky. So that's something to look out for with Venus.
It is, that's right, Pete. So dichotomy, the 50% illumination, is supposed to occur on the 28th of October, but it's best to start observing Venus a few days on that, maybe around the 25th, 26th, and that's probably when the planet will look 50% illuminated. If you observe it on the 28th of October, it will have the phase will have decreased to be something more like 49 or 48%. And as you say, this is this phase anomaly, which is even more pronounced in a blue filter. So if you observe Venus of the 28th of October with a Ratten 47 violet filter, the phase will look much less than 50%. And that was actually first really studied properly by BAA observers in the 50s and 60s.
Right, okay. Well, it's also worth noting that there's a 14% lit waxing crescent moon 2.2 degrees from Venus on the evening of the 9th of October, if you do manage to catch it after the sun has set. What about Mars then?
Oh dear. Poor Mars. It's in conjunction with the sun on the 8th of October, so not visible this month. But after that, it will slowly crawl back into the morning skies. And I think probably by what, Pete? February, March next year, it'll be reasonable placed in the morning sky to begin observation. But you'll need a large telescope because the apparent diameter will be quite small.
It will be very small, but of course that's leading up to the next opposition, which is early in December 2022. And that will be quite an exciting date because it's the 8th of December, because the moon occults Mars on the night of the morning, I think, of the opposition. So that's going to be quite something to go for. There's going to be a lot of people trying to get images of that particular event.
Yeah, that'd be great. And of course, Mars will be quite high in the UK skies, so that'll be good. It won't reach as large apparent diameter as it has the last few times, but it will still be a reasonable size. And we have Mars so for such a short period of time.
We do.
It's always best to try and make the best of it as soon as it becomes a viable target.
Yeah, absolutely. Okay, well, Jupiter is a viable target at the moment. It's magnitude minus 2.6, which is pretty bright, and reaches its highest position in the sky early evening, making it a convenient planet to observe during October. On the 1st of October, it's about 22 degrees above the southern horizon when it is due south, as seen from the centre of the UK. And that's not too bad, but it will improve over subsequent years as well. So it's getting a bit more exciting with Jupiter now.
Yeah, I have to say, those extra few degrees from last year have made all the difference to me.
Yeah.
I have found that I have been able to see quite a lot of fine detail on the planet with my 12-inch Newtonian. At the same magnification, sort of like 180 times last year, it was a blurred mess. It was very hard to see anything.
Yes.
But being a few degrees higher, it has made a stunning difference. So Jupiter is now a viable target for visual observers. I can't speak for you lot, but for visual observers, real astronomers, it's now back in the court. It's now back in play for those of us in the Northern Hemisphere.
Well, the same is actually in a slower sense starting to happen with Saturn as well, because Saturn is... Well, why'd you go,
Because I get 12 minutes to view Saturn. The amount of effort because it goes between the houses, I have to time it very carefully to get Saturn. It's actually about 17 minutes now because it's a bit higher. Last year it was about 12 minutes.
Is that because of the slopes of the roofs?
Yeah, it goes between the houses, so I have to time it, and I have to make a decision whether I want to do intensity.
You're getting a longer run now because it's getting higher.
I get 3 minutes more than last year.
Excellent.
I'm waiting for Saturn to be higher in the sky because all those fantastic things that you can image and observe with Saturn, the details in the rings and all that's wonderful stuff, and it's just very, very difficult to do at the moment. But as you say, Pete, Saturn slowly improving.
Yeah, I mean, Saturn's a beautiful planet to look at, but it does need to be a bit higher for us in the UK to get the best out of it, really. But it is slowly getting better. I think 2033 is probably when it's at its optimum. So we've got a little bit of time for it to keep crawling up. The best placed planet at the moment, of course, is the magnificent Uranus, which is...
Magnificent. Has anyone ever described it as that before?
Yes, I just have.
Clutching at straws, aren't we? Yeah. It is actually, well, to be fair to Uranus, it is actually a fascinating planet because it's unlike the others, it doesn't have all these striking surface features. It's quite an anomaly in terms of the planets of the solar system. But it is an interesting planet to observe, and people, particularly people with good imaging setups, have been able to record all sorts of storms. So I think amateur astronomers have really been able to show that the planet isn't quite as inert and boring as we thought it was. So for that reason, it is quite a very interesting planet.
Yeah, okay. Well, it reaches opposition on the 4th of November, so this is a great time to observe Uranus if you want to have a look at it. It's right on the edge of naked eye visibility at magnitude plus 5.7. But it does have a tiny disk. It's 3.8 arc seconds across, which is small, but it is visible with a small telescope. And it has that beautiful colour, of course. It appears quite greenish in hue. So that's good. It gets up to 52 degrees as well from the centre of the UK.
That is pretty good. Here's a little trick that I do when observing Uranus visually. I first look at Ganymede if Jupiter's about, and get some high power on Ganymede, and then switch to Uranus. And Uranus feels a lot bigger visually than Ganymede, and it's a little psychological booster that does always help. But you should be able to image the satellites of Uranus: Miranda, Ariel, Umbriel, Titania, and Oberon. I've seen a couple of them, brightest ones visually with my 8-inch reflector. Larger telescopes will show them visually as well.
Okay, well, Uranus is currently in Aries, just above the head of Cetus the whale. That strange sort of, it's like a distorted 50 pence piece shape with the orange giant Menkar, which is Alpha Ceti, in that shape. Neptune is...
Splendid Neptune.
Splendid Neptune, the only person ever to have described it as splendid. Neptune is fainter than Uranus. It's the only main planet which, in theory, you can't see with the naked eye. That's currently in Aquarius, drifting very, very slowly to the...
It's been near Phi Aquarii for what, a decade now?
Forever. I don't think it moves. Yeah, it has. Phi Aquarii is quite a useful star to locate it. It's magnitude plus 4.2, so that really helps as your anchor point to start with. But it was at opposition on the 14th of September. But to be fair, opposition doesn't make a great deal of difference to the ice giants, does it? Uranus and Neptune. There's not a great deal of difference in their appearance at opposition, unlike the closer in planets, Mars, Jupiter, and Saturn.
Yeah, that's true, yeah.
Okay, well, let's have a look at some of the special events happening during the month. And on the 3rd, we've got an occultation of magnitude plus 3.5 Eta Leonis. It'll be occulted by a 13% waning crescent moon on the morning of the 3rd. Should really observe from about 4:35 to 5:20 BST. But if you live right up in the northern part of the UK, it'll miss. In fact, there is a line which is mentioned in the magazine where the star will appear to just graze the northern edge of the moon. And that's an event, if you're in the right place, called a grazing occultation. I remember grazing occultations, actually. I did used to observe quite a few of them. I do remember a very exciting one night, because basically in the early days, the pre-digital days, to observe a grazing occultation where the star appears to clip the edge of the moon, it can go behind mountains and reappear in craters or valleys. So you've got lots of timings which you can do if you're in exactly the right position. And to get that timing right, you have to have a timepiece. And the way we used to do it, believe it or not, was to get the old analog tape decks, the portable ones, and used to bundle into a telephone box and record the speaking clock to give us a start point, and then keep the machines going, hand them out to everybody, and then when they saw the events, they'd go in, out, so you'd got the timing. But to also finish, because the tape stretches a little bit, you go back into the telephone box and you record the speaking clock again, so you've got calibration across the tape.
Wow.
Remember one night we did this, and somebody saw whoever was volunteered to go into the telephone box to get the recording, and they phoned the police thinking that they were up to no good. And so the police came along and had to actually convince them that we were actually trying to do some science. But those events were always sort of accompanied by a little bit of adventure.
Yeah, well, thank heavens for iPhones, or other phones are available. That have the accurate timing on there. I have a rugby clock in my observatory, but rarely use it because I've got the phone, the laptop, the iPad. They all keep very good times, so not a problem as it once was.
No,
all right. Well, moving on from Pete's dubious nighttime activities on the 4th, where this is a nice one to watch out for. The evening sees a rare opportunity to catch the shadows cast by Ganymede and Callisto onto Jupiter at the same time. That's quite a rare event, actually.
It is very rare, yeah.
Unfortunately, the event does begin in daylight, with Callisto's shadow transiting from 1700 UT, that's 1800 BST, but then later on Ganymede's shadow starts to transit at 1950 BST, or 1850 UT, and as Callisto's shadow is on the central meridian, Ganymede's shadow should be becoming prominent. So that's actually quite a nice one to watch out for.
It is, because Callisto's shadow moves slower than Ganymede's shadow. So even though
Callisto being the outermost of the 4 Galilean moons, it was very, very slowly.
Yeah, so basically, even though it starts to transit in daylight, you've got plenty of time to pick up on it. Okay, on the 8th, we've got the peak of the Draconid meteor shower, which has got a very weak ZHR of 5 meteors per hour, but has shown enhanced activity in the past, so it's worth keeping an eye out on it. But it's best seen in the early evening, and it's very favourable because the moon is out of the way. In fact, we've got a few meteors going on because we've got the peak of the Southern Taurid meteor shower on the 10th as well, which again has got a very low peak zenithal hourly rate of just 5 meteors per hour. But it's a broad peak. It lasts for several days. And you often hear stories of bright, slow-moving meteors associated with the Taurids, so it's worth keeping an eye out for those. And then on the 21st, we have the Orionid meteor shower, which is also quite low rates, about 20 to 25 meteors per hour at peak, but the moon will be just past full at the time the Orionids reaches its peak, so the shower will be severely compromised by that.
Yes, the moon will get in the way. Also on the 21st, Jovian moons Callisto and Io will transit the disk at the same time in the morning. They begin their transits together at 23:30 UT on the 20th of October, and this will carry on roughly 1 hour before Jupiter sets, so watch that over midnight. And that's, again, not quite a rare one. I don't think I have any drawings of Io and Callisto in transit at the same time.
Oh, that'd be good. Okay, so what about the stars? Well, as darkness falls, we've still got the out-of-place summer triangle, which is high in the sky with all the glories of summer.
The late summer triangle, maybe we should call it that.
Yes.
Yeah, so we've got plenty of glorious things in that. You can see, if you're in a darker sky, the Milky Way passing down through Cygnus, right down out till you reach the core of the galaxy down in the southwest in Sagittarius. But it is slipping away now.
It is.
And we're starting to get the familiar constellations of autumn slowly starting to appear.
We've got Jupiter and Saturn, of course, which are in Capricornus, the sea goat, which is an odd constellation, because I always describe it as looking like a triangular sandwich, because I don't know why, it just reminds me of that. But it is like a distorted sandwich, and it's supposed to represent a creature which is half goat, half fish, I believe. And the mythology around that's quite interesting, and it actually explains what's going on, well, as far as it can. But it's about the god Pan, who hurriedly entered the Nile to escape the monster Typhon. And in the panic, Pan only managed to adjust half his body because he was a goat-shaped god. So he ended up as half goat, half fish.
Right. That can't happen very often, presumably.
No, not at all. There's only one constellation, which is the sea goat. But southeast of Capricornus lays the small and insignificant, apart from one object, constellation Piscis Austrinus, the southern fish, which is easily identified thanks to, well, we always say this differently, don't we? I call it Fomalhaut, you call it Fomalhaut.
I do call it Fomalhaut. I think Patrick used to call it Fomalhaut as well. So if Patrick called it Fomalhaut, that's good enough for me.
It's the most southerly first magnitude star visible from the UK, but you do need to have a clear horizon to see it because it hides quite easily.
Yeah, it's actually quite an interesting star. We know that planet formation is going on around Fomalhaut at the moment. So one day there might be planets there, people looking back at Sol. So that's interesting. Okay. North of Capricornus and the constellation we've just been looking at is Aquarius, the water bearer. Now, this is actually a large constellation, but it is quite ill-defined. Two of its brightest stars, Alpha and Beta, they're there, but they don't really form much of a pattern, and the rest of the stars of the constellation are kind of vague, and
it is.
I find it quite a hard constellation to determine.
It is not easy, is it? I mean, you've got the small pattern, which is known as the water jar, or you could upset the purists because it's often about when you are observing the Perseid meteor shower, and it's quite distinctive. It's like a central star with 3 stars going off at 120-degree intervals, so it looks like the spokes of a steering wheel. So the meteor observers tend to call it the steering wheel. But that's a small pattern, and the 2 stars you mentioned, Alpha and Beta Aquarii, that's Sad-al Melik and Sad-al Sud, are reasonably bright. They do stand out fairly well, but the rest of the constellation is a little bit indistinct, I have to say. It's quite interesting actually noting that because this part of the sky, which is a bit wishy-washy, you could call you could call it watery, because it's actually known as the sea because it contains so many watery constellations. So you've got Pisces, you've got Aquarius, you've got Cetus, which is the sea monster as well.
Yes, and actually the brightest star here is Deneb Catos, the whale's tail, easily located by extending the eastern side of the Great Square of Pegasus south. The alpha star, Menkaure, is located in a sort of misshapen pentagon of stars, some distance to the northeast of Deneb Catos. And Menkaure glows with a distinctive orange hue as the star is coming slowly towards the end of its life. And we should also mention in Cetus that Mira, which was a red giant carbon star, was at maximum in mid-August, and this will now rapidly decline and get fainter and fainter.
Mira's good actually because it's easy to find because you've got that the faint cord which joins the two fish in the constellation of Pisces. The fish is. It sort of runs along the bottom edge of the Great Square of Pegasus and then up the eastern side, but it comes to a point at the star Alresha, which is Alpha Piscis. And that sort of point it comes to actually points directly at Mira. So that's a really useful way to locate it. But it does drop from peak brightness, which is typically in naked eye. Well, it is naked eye.
It can be naked eye. It is naked eye, yeah.
It drops from that really quickly, and then you need a telescope to see it at all.
Yeah, quite a large one, actually, because when it dips down, it gets very faint.
Yes, it does.
But yeah, so plenty to see in the October skies. We wish everyone clear skies, of course, and good luck with these special events. Thanks, Pete.
Thanks, Paul.